All right, let's talk about machine learning. We're going to do a foundational look at it today. Basically how computers learn to pull really meaningful information out of a whole bunch of data.
You know, when you boil it all down, machine learning is really just about one thing: finding patterns. And the data it sifts through, well, it can be pretty much anything that can be turned into numbers. We're talking stock prices, sounds, pictures of cats on the internet, even what movies you like to watch.
So that's the big question, right? How can a machine, which is, let's be honest, just a bunch of circuits and code, how can it actually learn to tell the difference between a meaningful pattern and just random noise? That's exactly what we're going to unpack here.
All right, so here's our game plan. First, we'll see what happens when simple rules just don't cut it. Then we'll get into learning with labels, and also how to find patterns without labels. After that, we're going to peek inside what's called a deep network. And finally, we'll uncover the secret sauce, how these things are actually trained.
Okay, first up, when rules aren't enough. To understand where we are now, we've got to go back in time a bit, to an early idea for machine intelligence that, well, let's just say it ran into a wall. So this idea was called an expert system. And on the surface, it sounds pretty logical, right? The thinking was, hey, let's just find a human expert, say a doctor or an engineer, and just write down every single rule they use to make a decision. Then we just feed those rules into a computer. Simple. Okay, let's make this super concrete. Imagine we're trying to teach a computer to recognize the number 7. We could come up with some rules, right? Rule 1, it's got a horizontal line at the top. Rule 2, it's got a diagonal line. And Rule 3, those two lines meet at the top right corner. Yeah, that seems pretty solid.
But, what about a 7 that looks like this? You know, the kind with the little bar through the middle? Our simple set of rules would just completely fail. The system would have no idea what it's looking at. And our only solution would be to go back in and manually add another rule just for this one specific case.
And right there, that's the core problem. This whole process of handcrafting rules, it has a name. It's called feature engineering. It's just incredibly brittle and honestly a ton of work. I mean, just try to imagine writing down every single rule a radiologist uses to spot a tumor in an X-ray. It's practically impossible.
So, if writing rules by hand is a dead end, what's the alternative? Well, this brings us into the modern era, starting with a powerful idea called supervised learning.
Supervised learning it's all about learning from examples. So instead of feeding the machine a bunch of rules, we give it pairs of data and the right answer. It's kind of like flashcards for a computer. You show it a picture of a tiger, and you also give it the label tiger. And you don't just do this once, you do it thousands, maybe even millions of times.
And what's amazing is that after seeing enough of these examples, the system starts to figure out the patterns all by itself. So when you show it a totally new picture it's never seen before, like these bananas or this cat here, it can look at it and say, yep, that's a banana with really high confidence.
Now, this is what I find really cool. The system isn't always 100% certain. Look at this picture of corn. Its best guess is ear, with about 60% probability. But it's also thinking, it could be corn, with a 40% probability. And that's a key takeaway. These systems give you probabilities, not just a simple yes or no. Okay, but what happens when you don't have all those nice, neat labels for your data? Or what if there isn't just one single right answer to a problem? Well, that's where our next couple of learning styles come into play. So first, there's unsupervised learning. With this one, we just hand the algorithm a giant pile of data. No labels, no hints, no answers. The whole point is for the machine to find hidden patterns and relationships in the data, all on its own. It's basically about finding natural groups of things that belong together. Think about it like this. An archaeologist uncovers this huge, messy pile of pottery fragments, all with different markings. An unsupervised algorithm could look at that total jumble on the left and automatically sort it into the neat, distinct groups you see on the right, just based on what the markings look like. It's finding connections that maybe no human ever even noticed. Okay, next up is reinforcement learning. This is what you use when you want a system to learn a really complex task, but you don't actually know the best way to do it yourself. It's all about learning through trial and error. The machine tries something, gets a score, or a reward, and over time, it just figures out which actions get it a higher score. It's like playing a giant game of you're getting warmer, colder, warmer. A really classic example of this is trying to schedule elevators in a huge office building. I mean, there's no one right answer for every situation. So a reinforcement learning system would just try out different strategies. They call them policies for moving the elevators around. It would get a score based on how long people had to wait. And after a while, it would actually discover the best, most efficient way to run those elevators for that specific building. So these different ways of learning, supervised, unsupervised, reinforcement, they're often powered by something you've probably heard of, deep learning. So now, let's actually pull back the curtain and take a look inside the guts of what's called a deep neural network.
Now this is super important to get straight. The deep in deep learning, it just means that the system uses a whole bunch of computational layers stacked one on top of the other. That's it. It has absolutely nothing to do with the machine having some kind of profound, deep understanding of the world. It's about structural depth, not philosophical depth.
And this diagram shows that flow perfectly. Let's just walk through it together. Okay, see the 4 inputs down at the bottom? The data starts there. It travels up to that first layer of circles. Now, as the information moves along each of those lines, it gets multiplied by a number called a weight. Then the circles in layer 1 do a quick calculation and pass the results up to layer 2, again getting multiplied by more weights along the way. And finally, layer 2 spits out the network's 2 final answers at the very top. It's just a flow of numbers from bottom to top.
But look, that whole structure, it's just a blueprint. It doesn't do anything on its own. The real magic, the thing that actually lets it learn, is the training process. This is really the secret sauce of the whole thing.
Remember those weights I mentioned on the lines? Well, they are everything. When you first build a network, those weights are just random numbers, so its answers are total garbage. The process of training is actually pretty simple in concept. You show the network an example, you'll look at how wrong its answer is, and then you go back and just slightly tweak all of those millions of weights to make the answer a tiny bit less wrong than next time. You just repeat that over and over. And this brings us right back to where we started. Remember the problem with those old expert systems? That impossible manual task of feature engineering? Well, this is the solution. Instead of a human writing the rules, deep learning lets the network figure out its own rules just by automatically adjusting all of those weights based on the data it sees. Which leaves us with a pretty fascinating and kind of mind-bending question. We know the system has zero common sense. It has no awareness, no real concept of what a cat or the number 7 actually is. It's just an incredibly sophisticated pattern matcher. So, if a network can teach itself the rules just by tweaking millions of numbers, can we really say it understands what it's doing? That's something to chew on.